There's Algebra. Mr. Lawrence here with your flipped lesson for Monday, March 5th. This is the review for the test. Okay, now I know it's been a little while since we talked about a couple of problems, but let's do a couple of the early ones really quick, and then we'll see how you do on the factored ones. All right, hold on 1 second. Let me get a couple problems up here. Okay, here's two problems that you can't see because the recorder's in the way. There we go. Here's two problems that you haven't seen in a little while, but they should be real simple. Remember, problems like these are not FOIL problems. How come? Because the quantities are being subtracted from each other. If they were being added, it'd be even more simple. I'm not even going to do one of those that's so simple. But since they're being subtracted, we have to be careful. Remember, this negative right here, this one right here, in both quantities must be distributed. All right, once it's distributed, it's an addition problem. You just combine your like terms. Go ahead and pause the video, see if you can do it, and then you'll see my solution when you're ready. If you're still watching at this point, I assume you want to see my solution. I'm going to distribute the negative in problem number 1, which means I'm going to multiply the second quantity through by -1. So that'll become a positive, a negative, and a positive. Now I'm ready to go ahead and combine like terms. Well, let me see here. Let me get a different color highlighter. There we go. I have 2x cubes in this first quantity. And the second quantity, I have a negative x cubed. Well, 2x cubed minus x cubed will be x cubed. Sure, piece of cake. All right, I'll get a different color highlighter here. Ooh, a lovely shade of pink. And let's see, I have an x squared here, a positive x squared. And here I have a positive x squared, don't I? Because after I distribute it. So I will get a positive 2x squared. Now, I don't see any plain old x terms, and I only see one constant, this -1. So my job is done. I just bring down the -1, and there we go. I am done. All right, if you're ready to see the solution for problem number 2, go ahead and keep watching. If not, pause and do the problem. I shall distribute the negative, multiply through by -1. So this will become a positive, a negative, and a positive. And this time, I'm not feeling highlighter-ish. I will circle my y cubes. I don't see any other y cubes, so I only have one of them. I'll put a square or a rectangle around the y squareds. I have a negative y squared there, positive y squared. They cancel each other out. All right, I have no y terms in this situation. It looks like I'll do an oval, -1 and a +6, and I know that 1 minus 6 is -5. That should be automatic by now, guys. You shouldn't have to stop and think. You know that 6 minus 1 is 5. You should know that 1 minus 6 is -5. So there is your answer. All right, that's stuff you can expect to see on the test, but it's so simple I don't think we need to spend too much time on it. All right, of course you could always go back and watch another video. I am going to put up 6 or 7 different types of problems. Your job will be to determine what type of factoring to use initially on them, and then to factor them. So I'm going to pause my video, get the problems up there, and they'll appear in just a moment. Okay, here's the 6 problems that I've chosen. Hopefully you can see them all. I'll tell you what, I'll scroll up. So A and B are obvious, and then there are C and D, and E and F. All right, you might want to jot those down in your notebook or on paper. Remember, you're supposed to be taking notes while you watch these videos. If you just watch them and blow through them, it's like daydreaming through class. How can you expect to learn if you're not paying attention? All right, you guys are extremely lucky to have this opportunity where you have access to the lesson 24/7. Anytime you need it, you have access to it as long as you have the internet. Okay. We didn't have that kind of stuff. I told you, we used to have to bang on the teacher's lounge to try to get Mr. Ruffer to come out and help us in honors AP Calc, and you know, he acted like we were inconveniencing him. So you are very fortunate to have this opportunity. All right, I am going to ask you to pause the video, see if you can identify which type of factoring to use on which problem, and then actually factor it. Okay, now remember, some of them might have more than one type embedded in them. So initially you'll be identifying the first type. All right, see what you can do with it. When you are ready, go ahead and unpause the video and you'll see how I do it. Okay, if you've unpaused the video at this point, I assume you're ready to see. I noticed right off the bat this first one is the difference of squares. Problem A is the difference of perfect squares. DOS, like the one video called it. My GCF is a W squared. I'm going to pull out a W squared, and I'll be left with a W squared minus 1. All right, but look inside. Oh, excuse me, I misspoke. This isn't the difference of squares initially. I was getting all excited because I recognized inside GCF initially. Yeah. All right, so GCF. Then inside here is the difference of perfect squares, right? The difference of squares. So I need to bring my W squared down. He just comes down. And then this W squared minus 1 factors as W plus 1 and W minus 1, both in quantity. Sorry about that. Got so excited that there was a difference of squares hiding in there, I blew the secret, so to speak. All right, that is completely factored, and I actually use two types of factoring, GCF and the difference of perfect squares. All right, B. There's 4 terms. That should be a hint. This is going to be a grouping problem. Now, remember with grouping, you have to have GCFs. I notice that I have a GCF. I have a GCF between the first and second terms, and I also have a GCF between the third and fourth terms. So I'm good to go. Remember, I'll grab the sign and always put an addition between. The GCF here looks like it's an X. I'll factor it out. I'll get Y plus 5 plus the GCF here is a 3. Factor it out, and I'll get a Y plus 5, and notice the Y plus 5 shows up twice on both sides of the plus sign. I'll pull him out and be left with an X plus 3. And there we go. There we go. All right, this third one, well, there's no GCF. I mean, GCF is 1, and that doesn't do us any good, so no practical GCF that we're going to use. Difference of squares won't work because there's not 2 terms. It's not a perfect square trinomial because 10 is not a perfect square. So I'll try the trinomial method. All right. I'll list the factors of 10, 1 and 10, 2 and 5. This is negative, so I know that I'm going to subtract. I want to take 2 factors of 10 and subtract to get negative 3. Subtract to get negative 3. Well, that looks like it's going to be 2 minus 5. All right, I'll have a quantity of x and a positive 2 and a quantity of x and a minus 5. These are easy when the lead coefficient is 1. They're that simple. All right, this second one here, again, it looks like the trinomial method, right? Looks like the trinomial method. I'll list the factors of 2. I need to add this time to get positive 5. Well, there's only 2 factors of 2, 1 and 2. And 1 plus 2 never equals 5. This one cannot be factored. We can call it prime. We can solve it, but it's we're going to need something called the quadratic formula, and that is a topic for another day. All right, so both of these use the trinomial method, except the second one, D, revealed that the problem was in fact prime, meaning it can't be factored. All right. Coming down here to 9, well, it looks like a trinomial problem, and I could do it using the trinomial method, except I notice that this is a perfect square, and its square root is 3x. This is a perfect square, and its square root is 4y. And if I multiply the perfect squares, I get 12xy, and double it, I get 24. This is a perfect square trinomial. And why is it important to know that? Because it'll save me 10 minutes of factoring. Watch. When it fits the perfect square trinomial, the first term is a perfect square, the second term is a perfect square, the middle term is twice the product of the roots. When that happens, it's a perfect square trinomial, and it factors just like this. 3x and a 4, 3x and a 4. Now some of you get confused on the signs. Remember, there's a plus back here. This guy shows up twice. It's the Wendy's double stack. In a trinomial, when that third term is positive, the middle sign will show up in both quantities. It only works when the third term is positive. If the third term is negative, you get one of each. Okay, so let's jump on over here to problem F. And you know what? Some of you are going, I'm just going to use the trinomial method. But I notice a 6, a 24, and a 6. I'm going to pull out a GCF first of all. GCF is my first type of factoring to use. I'll get n squared minus 24. Oh, no, I won't. I'll get n squared minus 4n plus 1. And looking at that, I think that's all I can do. I won't call it prime because I pulled out a GCF. This part here is prime, meaning I can't factor it down anymore. But the whole problem is not prime because I pulled out a GCF. All right, I got one more problem I want to show you. Hold on one second. Okay, this is a trinomial. It does not have a GCF, and this is one where I have to list the factors of two numbers. I have to list factors of 10, like this, and then I have to list factors of 21. And I believe that's it. Now, this guy here is negative, so I'm going to combine factors, but when I do so, I'm going to subtract, and I have to get -1 for an answer. Well, look at this. That's 14, right? And that's 15. And I want to get -1, so the 15 has to be negative and the 14 has to be positive. These are my coefficients on x. 3x and 7x. Okay, I multiply the 7 by 2, so I multiply the 7 by 2. I multiply the 3 by 5, so I multiply the 3 by 5. All right, I need the 15 to be negative. I need the 14 to be positive. And there you go. It's that simple. That simple. I would definitely expect to see that. The kid who really wants an A, they're going to have to be able to do this type of problem. That's what's going to take for you to earn an A on this test. All right. Not too long for a review video. Plus, remember, guys, you can always go back and review videos from things you didn't understand. All right, Mr. Lawrence signing off. Good night and good luck, everybody.